Question 1. In light of recent developments, Hassan, an energy assessor, is reviewing an OTU rooftop unit serving a 15,000 SQ or commercial facility. His airflow measurement shows 300 CFM per ton. The system uses DX cooling, and psychrometric data suggests high indoor RH levels, 65% plus, despite the system operating at capacity. What is the most likely cause contributing to inadequate heat removal? A. The evaporator coil surface area is too large for the load. B. The system airflow rate is too high, reducing moisture removal. C. The condenser is oversized, leading to inefficient cooling. D. The thermostat is improperly calibrated, causing short cycling. Answer. Correct answer. B. Explanation. High airflow per ton above 400 cm/ton is common for sensible loads, reduces contact time across the evaporator coil, compromising dehumidification. At 300 cm/ton is marginal, but if latent load is high, it may still be insufficient. The system cannot adequately lower indoor RH if latent heat is not removed. ASHRAE 62.1 and psychrometric principles support this. Oversized coils, they may improve moisture removal. Oversized condensers, C, affect compressor runtime, not humidity. Thermostat issues, D, could lead to short cycling, but sustained RH points to airflow-related inefficiencies. Question 2. To what degree does demand-controlled ventilation, DCV, contribute to HVAC energy savings in commercial office buildings? A. It maintains constant outdoor air ventilation regardless of occupancy. B. It increases supply airflow during unoccupied hours for dilution. C. It reduces ventilation rates during no occupancy periods based on code levels. D. It disables economizer function during periods of high outdoor air enthalpy. Answer. Correct answer. C. Explanation. DCV dynamically adjusts outdoor air intake based on occupancy using code sensors, reducing energy usage during low occupancy. ASHRAE 62.1 allow DCV in zones with predictable occupancy variance. A is incorrect because DCV is specifically for variable, not constant ventilation. B would waste energy. D refers to economizer lockout, unrelated to DCV's primary function. Studies show DCV can reduce energy use by 2.30% in low utilization zones. Question 3. Through careful analysis of system performance, an auditor observes that a geothermal heat pump has an EA of 25 but a COP of only 2.5 during heating. What does this disparity suggest about the heat pump's seasonal performance characteristics? A. The cooling cycle benefits from ground loop efficiency while heating is electric resistance. B. The unit is malfunctioning since the COP should be equal to EA. C. The heating load exceeds the cooling load, impacting average efficiency. D. The COP is low because it includes auxiliary strip heat used in colder months. Answer. Correct answer. D. Explanation. A low COP compared to a high EA in geothermal systems often indicates use of auxiliary electric resistance heating. This skews winter efficiency, while EA cooling is 25, a COP of 2.5 reflects much higher energy use than BTU of heat delivered in heating. This is normal in some climates unless backup strip heat is optimized. EA and COP are not equal. B. A misunderstands COP's meaning. C is misleading. Load size doesn't alter unit rating but may affect runtime. Question 4. Under the assumption that an assessor is conducting an ASHRAE Level 2 energy audit in a school building with multiple HVACR systems, what is a required activity during this level of audit? A. Installing permanent submeters for long-term monitoring. B. Performing detailed simulation modeling for all zones. C. Conducting short-term measurements of key systems. D. Interviewing occupants about satisfaction with lighting. Answer. Correct answer. C. Explanation. ASHRAE Level 2 audits involve short-term data logging, deeper system analysis, and actionable ECMs. Permanent submeters and full simulations B are typically Level 3. Occupant interviews D are more typical of Level 1 for quick benchmarking. Level 2 bridges preliminary assessment and investment grade analysis. Refer to ASHRAE procedures for commercial building energy audits. Question 5. Taking into account system dynamics, which condition would most likely indicate a malfunctioning thermostatic expansion valve (TSV) in a residential split system? A. High superheat and low suction pressure. B. Low subcooling and high head pressure. C. Elevated suction temperature and subcooling. D. Low compressor amps and high evaporator pressure. Answer. Correct answer A. Explanation. A malfunctioning ESV often restricts refrigerant flow, causing low evaporator pressure and elevated superheat. The TSV regulates flow based on superheat, and if it sticks closed or underfeeds, staffed coils resolve. B suggests liquid line restriction. C contradict TSV effect. D indicates underloading, but not specific TSV issues. HVACR diagnostic standards and refrigeration cycle principles per Assessor training and NATE resources confirm this behavior. Question 6. When considering infiltration loads during an energy audit of a poorly sealed structure, which of the following most directly impacts infiltration rate calculations? A. Number of air handlers in operation. B. Orientation of the building to the sun. C. Stack effect caused by temperature differences. D. The total surface area of interior partitions. Answer. Correct answer C. Explanation. Stack effect. Pressure differentials due to indoor-outdoor temperature differences is key driver of infiltration. It increases during winter in tall buildings. Air handlers A may contribute to pressure imbalances but are secondary. Sun orientation B affects solar gain, not infiltration. Interior partitions D do not directly affect infiltration. Refer to ASHRAE Handbook. Fundamentals chapter on infiltration and ventilation for detailed modeling. Question 7. As demonstrated by Istalai, an energy assessor preparing a client report on HVACR retrofit ROI, which of the following best describes a professionally appropriate approach to presenting his findings? A. Highlight only payback period shorter than 5 years to secure funding. B. Present all data with assumptions clearly stated and limitations disclosed. C. Use industry jargon extensively to demonstrate technical knowledge. D. Avoid discussing uncertainties to prevent client confusion. Answer. Correct answer B. Explanation. Clear, transparent reporting with disclosure of assumptions and limitations is best practice per ASHRAE and DOE guidelines for energy assessments. A is unethical cherry picking. C. May confuse clients, reducing credibility. D. Neglects informed decision making. Ethical communication builds trust and aligns with professional guidelines such as E-Code of Ethics and ANSYCIA audit reporting standards. Question 8. The impact of installing a 5 HP motor with a AE in place of a standard motor operating at full speed constantly can be most accurately described by which statement? A. Energy savings are negligible unless load is near peak. B. VFDS reduce energy use by varying speed to match load. C. Efficiency gains are irrelevant due to constant torque loads. D. Full speed operation is more efficient for variable loads. Answer. Correct answer B. Explanation. VFDS variable frequency drives enable motors to match output to load, reducing power per affinity laws, especially for fans pumps. Savings increase exponentially as speed decreases. Cube law. A and C. Misunderstand load dynamics. D. Contradicts efficiency principles. Refer to DOE's Motor Systems Market Assessment and ASHRAE 90.1 for motor integration guidance. Question 9. Despite the fact that R400 TINA has no ozone depletion potential, why is it still being phased down under international and national regulations? A. It reacts with atmospheric oxygen, forming acid rain. B. It has a high global warming potential WE. It causes compressor overheating due to miscibility. D. It requires high-pressure compressors, increasing energy use. Answer. Correct answer B. Explanation. R400 TINA has OU1000 contributing significantly to greenhouse effective leak under the Kigali Amendment to the Montreal Protocol and US AIM Act. HFCS like R400 TINA are being phased down. A is incorrect. No acid formation occurs. C and D are technical issues, but not regulatory justifications. Environmental regulation trends favor DOE refrigerants like R32 or R454. Question 10. Based on the information, ISPREA is auditing a chilled water plant that has automated controls and a building automation system (BAS), she notes that chilled water set points are fixed year-round. Which control strategy could improve seasonal energy performance? A. Implementing fixed temperature resets during peak hours. B. Adding constant volume pumps for baseline cooling. C. Using outdoor air reset schedules for chilled water temperature. D. Disabling BAS alarms to reduce nuisance shutoffs. Answer. Correct answer. C. Explanation. Outdoor air reset modifies set points based on ambient conditions, reducing unnecessary overcooling during mild weather. This optimizes chiller efficiency. A. Fixed resets don't respond to conditions. B. Constant volume pumping wastes energy. D. Disabling alarms is major safety risk. Refer to ASHRAE Guideline 36 and 2021 Energy Code recommendations for optimized control sequences. Question 11. From a practical standpoint, Mr. Garcia inspects a commercial refrigeration system and notices the compressor's discharge temperature is abnormally high despite normal head pressure readings. Which of the following is the most probable cause? A. Overcharged refrigerant causing liquid slugging. B. Insufficient condenser airflow reducing heat rejection. C. Excessive superheat causing vapor compression inefficiency. D. Malfunctioning expansion valve flooding the evaporator. Answer. Correct answer. B. Explanation. High discharge temperature with normal head pressure often indicates poor heat rejection due to low condenser airflow, causing compressor overheating. Overcharge A. Typically raises head pressure. Excessive superheat C. Raises suction temp, not discharge temp primarily. Flooded evaporators D. Usually cause low superheat and suction pressure issues. ASHRAE fundamentals and manufacturer guidelines highlight condenser airflow as critical to compressor health. Question 12. In a modern context of energy auditing, when evaluating heat loss through windows, which factor most significantly affects the accuracy of load calculations? A. The U-value of window glazing and frame combined. B. The color of interior wall paint near the window. C. The total window width regardless of height. D. The orientation of the HVAC system near the window. Answer. Correct answer A. Explanation. Window heat loss depends heavily on the combined U-value, thermal transmittance of glazing and frames, which quantifies conductive and convective heat flow. Interior paint color. B. Affects radiant heat minimally. Window dimensions matter, but combined height and width. C. Effect area, not accuracy alone. HVAC system orientation. D. Is unrelated. ASHRAE Handbook. Fundamentals clearly stresses U-value importance for envelope heat transfer modeling. Question 13. Considering the evidence in industrial facility plans to retrofit 3 large pumps with VVFDS, which aspect should the energy assessor emphasize when calculating the payback period? A. The pump's full load operating hours only. B. The potential reduction in peak demand charges. C. The decrease in total pump runtime during low load periods. D. The increase in pump speed capacity for future loads. Answer. Correct answer. C. Explanation. VVFDS seduce energy by lowering pump speed and runtime when full flow isn't needed, so total runtime reduction during low load is key to energy savings and payback calculations. Full load hours A. Underestimate savings. A peak demand charges B. Are relevant but secondary. Increasing pump speed D. Is rarely a benefit for energy saving. ASHRAE and DOE motor system guides focus on load variability as prime energy saving factor. Question 14. Within the framework of energy efficiency, which duct design factor most influences fan energy consumption? A. Duct material color reflecting radiant heat. B. Total duct surface area in the conditioned space. C. Duct system static pressure due to friction and fittings. D. Number of supply diffusers installed per room. Answer. Correct answer. C. Explanation. Static pressure from duct friction and fittings directly affects fan power consumption. Higher static pressure forces fans to work harder. Duct color A affects heat gain but not fan energy. Surface area B relates to heat loss gain but not fan load. Number of diffusers D affects air distribution, not fan energy directly. ASHRAE 90.1 and fan laws confirm duct static pressure as key energy driver. Question 15. Taking into account an energy audit of A chilled water system is Kim observes the chilled water reset schedule is based solely on return air temperature. What is a limitation of this control strategy? A. It fails to account for varying outdoor air conditions. B. It can lead to excessive cooling during unoccupied periods. C. It increases pump energy consumption unnecessarily. D. It results in improper refrigerant charge in the system. Answer. Correct answer A. Explanation. Resetting chilled water temp based only on return air ignores outdoor air effects, which strongly influence load and system efficiency. Outdoor air reset provides more comprehensive adaptation. B and C could be secondary effects, but are not inherent to return air reset alone. D relates to refrigeration charge unrelated to control strategies. ASHRAE Guideline 36 emphasizes multivariable resets for optimal control. Question 16. When evaluating the merits of using natural gas versus electric resistance heating in a commercial building, what primary factor influences the choice from an energy cost perspective? A. The carbon emissions associated with each fuel. B. The efficiency of energy conversion and local fuel prices. C. The installation cost of electric versus gas equipment. D. The noise levels generated by the heating equipment. Answer. Correct answer. B. Explanation. Energy cost analysis centers on conversion efficiency, gas furnace 80.95% versus electric resistance 100% and local utility rates. Even if electric is 100% efficient, natural gas is often cheaper per unit energy. Carbon emissions A are environmental but less directly cost-related. Installation cost C and noise D are secondary. Refer to energy economics principles and utility tariffs in audit cost-benefit analysis. Question 17. Across different scenarios, Mr. Patel is considering integrating solar thermal preheating into a commercial hot water system. What is a key limitation he should evaluate? A. Solar thermal systems increase refrigerant charge in HVAC equipment. B. Effectiveness depends heavily on solar insulation and system design. C. They significantly increase HVAC system maintenance frequency. D. Solar thermal can only be used in residential applications. Answer. Correct answer. B. Explanation. Solar thermal's effectiveness hinges on solar availability and proper design to match load profiles. A and C are unrelated. If solar thermal doesn't affect refrigerant charge or HVAC maintenance notably, D is false. Commercial solar thermal applications are common. ASHRAE and DOE guides highlight insulation variability as the critical design consideration. Question 18. In the context of an energy audit report, the assessor finds that replacing an old chiller with a high-efficiency model reduces energy use by 25%, but initial costs are high. How should the assessor best present this information to the client? A. Recommend replacement solely based on energy savings. B. Provide detailed payback period and life cycle cost analysis. C. Suggest postponing replacement due to high capital cost. D. Focus only on environmental benefits to encourage funding. Answer. Correct answer. B. An explanation. Comprehensive ROI and life cycle cost analysis gives the client objective data for informed decisions. Solely recommending replacement A or postponing C lacks nuance. Environmental benefits D are important but insufficient alone. ASHRAE's energy audit guidelines recommend balanced financial and environmental analysis. Question 19. Within the framework of ASHRAE Standard 90.1, how does the standard address energy efficiency in HVAC systems during building commissioning? A. It requires commissioning to verify installed equipment matches design specs and operates efficiently. B. It mandates the use of only electric resistance heating for efficiency. C. It disallows the use of variable speed drives in HVAC systems. D. It specifies minimum duct sizes for aesthetic purposes only. Answer. Correct answer A. Explanation. ASHRAE 90.1 requires commissioning to ensure systems meet design, intent, and energy efficiency goals. B is false. The electric resistance heating is generally least efficient. C contradicts the standard's encouragement of EADS for energy savings. D is unrelated. The duct sizing is for airflow and efficiency. Commissioning per 90.1 improves overall system performance and occupant comfort. Question 20. By evaluating the psychrometric chart during a humidity control assessment is one notices the air conditioning system is cooling air below its dew point but the supply air temperature remains higher than design. What is the likely impact on space conditions? A. Increased latent load causing moisture accumulation. B. Reduced sensible cooling capacity leading to discomfort. C. Overcooling leading to excessive humidity removal. D. Elevated supply humidity causing mold growth. Answer. Correct answer. B. Explanation. If supply air is cooled below dew point but still warmer than designed, latent load removal occurs, but sensible cooling is insufficient, causing thermal discomfort. A is unlikely because moisture condenses below dew point. C and D contradict psychrometric principles. The elevated humidity would not result from air cooled below dew point. ASHRAE fundamentals and psychrometrics guide these analyses. Question 21. When faced with a scenario where an air conditioning system shows a declining SEER rating over time despite regular maintenance, what is the most likely underlying cause affecting system performance? A. Progressive refrigerant leakage leading to lower charge levels. B. The compressor operating at a higher efficiency due to wear. C. Increasing outdoor temperature beyond design limits. D. Improvements in indoor air filtration reducing airflow. Answer. Correct answer. A. Explanation. Refrigerant leakage reduces system capacity, causing the compressor to work harder, lowering efficiency and SEER. Compressor wear typically decreases efficiency. B. While outdoor temperatures. C. Effect load. SEER is standardized to design conditions. Better filtration. D. May slightly reduce airflow but would not significantly reduce SEER unless extreme. ASHRAE 90.1 and manufacturer guidelines emphasize refrigerant charge as critical for performance. Question 22. Given the circumstances, an energy assessor notices cavitation noises in a chilled water pump. What is the primary cause of this phenomenon? A. Excessive suction pressure causing fluid vaporization. B. Insufficient net positive suction head NPSH leading to vapor bubble formation. C. Oversized pump running at low speeds. D. Air trapped in the discharge piping. Answer. Correct answer. B. Explanation. Cavitation occurs when local pressure drops below fluid vapor pressure, creating vapor bubbles that collapse violently, causing noise and damage. Insufficient NPSH is the main cause. Excessive suction pressure A would prevent vaporization. Oversized pumps C can cause efficiency issues but not cavitation. Air in discharge D may cause noise but not classic cavitation. Hydraulic and pump standards highlight NPSH as key to prevent cavitation. Question 23. Throughout the course of an energy audit, why is it critical to perform benchmarking of energy consumption before recommending ECMs? A. Benchmarking helps to identify baseline performance and prioritize improvements. B. Benchmarking allows the auditor to avoid data collection on site. C. Benchmarking eliminates the need for system performance testing. D. Benchmarking guarantees energy savings after ECM implementation. Answer. Correct answer. A. Explanation. Benchmarking provides a baseline for energy use, enabling identification of inefficiencies and prioritization of ECMs with highest impact. It does not replace data collection, B, or system testing. C, and cannot guarantee savings. D, as savings depend on proper installation and operation. ASHRAE and DOE audit protocols emphasize benchmarking as a fundamental audit step. Question 24. In what ways can harmonic distortion caused by nonlinear loads impact an HVACR system's electrical performance? A. It improves the power factor by reducing reactive power. B. It can cause overheating of transformers and neutral conductors. C. It reduces motor efficiency by increasing voltage. D. It prevents circuit breakers from tripping during faults. Answer. Correct answer. B. Explanation. Harmonics cause excessive current in neutral conductors and transformers, leading to overheating and premature failure. A is incorrect. Harmonics typically worsen power factor. C. Voltage is not increased by harmonics. Motors may overheat due to distorted currents. D. Is false. Harmonics do not prevent breaker tripping. Standard 519 covers harmonic mitigation in HVACR systems. Question 25. In light of recent developments, how do energy recovery ventilators (ERVs) contribute to HVAC system efficiency in humid climates? A. By transferring only sensible heat, ERVs reduce latent loads minimally. B. By transferring both sensible and latent heat, ERVs reduce humidity and energy use. C. ERVs increase outdoor air volume to dilute indoor pollutants regardless of climate. D. ERVs function primarily as backup heating systems during winter. Answer. Correct answer. B. Explanation. ERVs transfer both sensible heat and moisture between exhaust and incoming air streams, reducing latent load and energy needed for dehumidification. A. Describes heat recovery ventilators HRVS, which transfer only sensible heat. C. Ignores ERVs' moisture transfer role. D. Is false. ERVs do not provide direct heating. ASHRAE 62.1 references ERVs for humidity control in humid climates. Question 26. Given the circumstances, Anderson recommends installing programmable thermostats in a small office building. What key factor determines the actual energy savings achieved by this ECM? A. The precision of thermostat temperature display. B. Occupant compliance with programmed schedules. C. The building's insulation R values. D. The color and style of thermostat housing. Answer. Correct answer. B. Explanation. Energy savings depend heavily on occupants using the programmed schedules properly. Without compliance, savings are minimal. Display precision. A. Insulation. C. And housing aesthetics. D. Have negligible effect on thermostat performance. This is supported by multiple studies on behavioral impacts on energy efficiency. Question 27. When analyzing a split system air conditioner operating in a humid climate, what is the primary mechanism responsible for removing moisture from the indoor air? A. Cooling the air below its dew point on the evaporator coil, causing condensation. B. The action of the blower increasing air velocity through the ducts. C. Heating the air to increase its moisture holding capacity. D. Using UV lights to break down water molecules in the air. Answer. Correct answer. A. Explanation. Moisture removal happens when air is cooled below dew point, causing water vapor to condense on the evaporator coil and drain away. Air velocity. B. Affects air movement, not dehumidification. Heating. C. Adds moisture capacity but does not remove moisture. UV lights. D. Improve air quality but do not directly remove moisture. ASHRAE Handbook and psychrometric principles support this. Question 20. In terms of evaluating system efficiency, how does the coefficient of performance, COP, differ fundamentally from the energy efficiency ratio? A. COP is dimensionless, representing ratio of heat output to electrical input. E uses BU and watts. B. COP only applies to electric resistance heating systems. E applies to all systems. C. COP is used exclusively for heating systems, while E is for cooling. D. COP values are always lower than E values for the same system. Answer. Correct answer. A. Explanation. COP is a unitless ratio, heat output divided by electrical input, while E is expressed in BTU divided by watts. COP can be converted to E by multiplying by 3.412 conversion factor. B and C are false. A COP applies to heat pumps and cooling, and E applies to cooling. D is not necessarily true. Values depend on units. ASHRAE fundamentals define these metrics clearly. Question 29. As illustrated by best practices, what is the most critical component of an energy audit report for a commercial building? A. A detailed list of all equipment make and models on site. B. Clear identification of recommended ECMs with cost-benefit analysis. C. Inclusion of the auditor's professional biography and certifications. D. Photographs of all mechanical rooms and ductwork. Answer. Correct answer. B. Explanation. The core purpose of an audit report is to present ECMs with clear cost, savings, and payback information for client decision-making, while A, C, and D add value. They are supplementary. ASHRAE and DOE audit protocols emphasize transparent, actionable recommendations. Question 30. From the perspective of ensuring HVAC system safety and efficiency, why is conducting combustion analysis on gas-fired equipment essential? A. To maximize electrical consumption by ensuring constant fan operation. B. To verify proper fuel-air mixture, optimize efficiency, and reduce harmful emissions. C. To eliminate the need for routine maintenance by perfect calibration. D. To guarantee zero carbon monoxide production under all conditions. Answer. Correct answer. B. Explanation. Combustion analysis checks fuel-air ratios to ensure complete combustion, maximizing efficiency and minimizing current NOx emissions. They is unrelated. Perfect calibration does not eliminate maintenance. C. Zero code. D is ideal but rarely guaranteed under all conditions. Safety standards. E. G. NFPA 54 mandate combustion testing.